Hi guys, in this video we're going to talk about the history of Dalton's atomic model of the atom, and we are going to start by looking at ancient Greece because that's where it all starts. So a long time ago there was this philosopher named Empedocles, and Empedocles was alive a long time ago in BC times. Remember, those count backwards. 492 to 432 is when Empedocles was around. And he said that there are 4 elements, and you may have heard about these before. They used to classify things as either fire, air, water, or earth. And anything that you could touch or hold was usually earth, and if it was a liquid, it was water. Anything that you couldn't really see was in the air, and fire was those things that glow. So they didn't have electricity to think about light bulbs and TVs, so those didn't fit anywhere. While Empedocles was alive, there was this guy named Democritus who came along and thought about stuff. He was around from 460 to 370. Remember, we're counting backwards, so that's how this goes. And he said that everything is made of, and he used the word atomos, which is, the idea here is that if you cut stuff up, you'll get to the smallest thing, and that will be an atom. And he said that atoms are specific to each material. So my pen has a different set of atoms than the paper, and the paper has a different set of atoms than the tabletop, but everything is made up of these tiny atoms. So then the Dark Ages happened, and nobody really thought about anything, and a long time later, in another period called the Renaissance, there was this guy named Robert Boyle, and he was around in 1660, and he said that elements are fundamental substances. So everything is made up of these elements, and he said that they can't be broken down further. So you can break stuff down to the elements, but once you get to elements, you're stuck by chemical means. You can't break them down by chemical means. So he agreed with Democritus that there are these things called atoms, and you can't break them up. And fast forward just a little bit, well, okay, maybe it's more like 100 years. There was this guy named Joseph Priestley, 1773, and he said that some substances can be broken down. Some substances can be broken down, but that when you break them down into their elements. So he's talking about molecules here. Some substances can be broken down into 2 or more parts. And he was talking about molecules. So those elements are all the same particles, and molecules have different particles or different atoms stuck together, and he was talking about those particles that you can break apart. And he found this out because he broke up water, like we did, into 2 gases, and he said, wow, those are very remarkably different. So just a couple of years later, this French dude named Antoine Lavoisier, he's got a lot of I's in his name, Antoine Lavoisier, and he was just a couple years later, 1778, he said that those gases that came out of the water, he named the gases hydrogen and oxygen. So Joseph Priestley didn't know what those gases were, and Antoine Lavoisier said what those gases were. And while he was at it, he also showed that mass is conserved. We did that in our first unit this year, and that comes from the work that Antoine Lavoisier did. He found that it didn't matter what kind of process you used, that you always had the same mass as long as you could account for all of it in a closed system. All right, fast forward just like 20 years or so, 10, 20 years. There was this guy named Joseph Proust in 1799, and he said that when particles interact, when there's a reaction, reactions happen in defined proportions. And what that means is that when particles come together, they come together in a set proportion, like 2 pieces of bread and a piece of lunch meat and a piece of cheese make a sandwich. But if you only have 1 piece of bread, it's not going to be the same sandwich. So, law of definite proportions is what we call that philosophy there. All right, so now we're finally to this guy, John Dalton. John Dalton, 1803. So what he did was he kind of summarized everything that people had already been saying about atoms and what they do, and what matter is made of. And so he wrote it down in some points. And the first one is that matter is composed of atoms. So everything is made up of atoms. He said that all the atoms of an element, I'm going to run out of room there, all the atoms of an element are identical, and they are different, they are different from other elements. So they're not the same as other elements. All the elements have different atoms. And when you have a reaction, reactions involve combining atoms. So when you have a reaction, it would be a lot like when you play with Legos. You have some Legos that are stuck together, and you take them apart and you build something new. That's what happens in a reaction. And I'm going to run out of room here too. The last thing that he said is that compounds are combinations of atoms in whole number ratios. And what that means is that you don't have pieces of atoms. So if you have water, you can't have half of a water molecule. That would be what? Half of an oxygen and 1 hydrogen. That doesn't make any sense. So you can't have pieces of atoms. You only have whole number ratios. So that's the history of where all of this thought came from, and there were experiments that led to all of these ideas. It's definitely based on evidence. So let's review a couple of things we've already talked about. First off, atoms are single units of an element, and I'm going to throw in molecules because they're a little bit different. Molecules are single units of compounds. That's how we're going to be using the term here. So single units of elements are atoms. A single piece of a compound is a molecule, and an element is that fundamental substance that can't be broken down by chemical means. Okay, so, there you can't see it there. An element can't be broken down by chemical means. You can break something up by physical means, and once you get to the very bottom, you can't break it down any further. Maybe you tried some chemical means and it didn't work, then what you have is an element. Compounds are combinations of 2 or more atoms, and they can be broken down. So elements can't, compounds can be broken down by chemical means. Now, to contrast here, we're talking about chemical means. Mixtures, you don't even need chemical means. Mixtures can be separated by physical means. We did that with several mixtures already, physical means. We looked at those different pieces and how, I don't think I showed you the other one, chemical means. We looked at how to separate different kinds of mixtures based on their properties. So Okay, so up here we talked about this guy, Joseph Proust, who talked about the law of definite proportions. We're going to write it down over here. It says that elements, I'm going to write it over here, elements combine or react. They come together, that's the point here, in definite proportions. And an example that I like a whole lot is water. Water is a 2-to-1 ratio of hydrogen and oxygen. You have to have 2 hydrogens for each oxygen in order to have water. H2O. Okay? So anything that's not 2 hydrogens and 1 oxygen is not water. It's something else. So there's this stuff called H2O2. There's a 2 there. It's definitely not water. In fact, it's hydrogen peroxide, which you can clean cuts with, but it's definitely not for drinking. You need to drink water. You don't want to drink hydrogen peroxide. So different ratio means it's a different element. In fact, that's what this law of multiple proportions says. Elements combining to form more than one compound. Elements combining to find more than one compound will still have small whole number ratios. And we say small, generally it's less than 10. There aren't a lot of molecules that have more than 10. There are some pretty big, ridiculous molecules that have lots of little pieces in them, but most of them have less than 10 particles, less than 10 atoms. So what this means, just like this H2O is water and H2O2 is not, the same idea is here. Here's some more examples. There's this CO stuff called carbon monoxide, which you probably heard of. Carbon monoxide is something that you don't want to breathe it in because it actually poisons your brain. But then there's this other stuff called CO2, which is carbon dioxide, which you don't want to be only breathing in carbon dioxide because it doesn't do you any good, but you breathe out carbon dioxide. So it is not as harmful as carbon monoxide is. They are 2 different compounds, but they still have small whole number ratios. This one is a 1-to-1 ratio, and this one is a 1-to-2 ratio. So this is a little bit about the history of the atom and some information that you need to know about atoms and molecules and elements and compounds. Thanks for watching.